Suppose we know that x is log base 5 of 20. We need to know how to evaluate log base 5 of anything. Well, because our calculators or our tables of values are just for common or natural logarithms, we don't have tables probably for log base 5. Well, if we have a logarithm equation, we could put it into exponential form. Let's do that and see what happens. Then we'll end up with 5 to the x power equals 20. We're looking for some power of 5 to equal 20. All right, well, now we have an exponential equation. So what are we going to do? Well, when we have an exponential equation, we're supposed to take the logarithm of both sides. So let's take base 10 log of both sides. If we take the log of 5 to the x, is x log 5 equals log of 20. Well, that's base 10 logs now. So we could look these numbers up. That means that x is equal to the log base 10 of 20 over the log base 10 of 5. When we actually do this calculation, which we can do now using our calculator or our tables, we'll find out that the log base 5 of 20 is actually 1.86. A lot of other decimal places there. So we'll say, let's round it off to 1.86. Well, this helps us because it gives us a way to do this on a regular basis. What we see here is that the log of 20, well, 20 was our original value here, called the argument of the log. And we see that on the denominator, we were taking the log of the base. So in general, we could write that the log base b of a is equal to the log of a divided by the log of the old base. Now, in fact, we could use any other base here besides 10 or e, but the change of base formula, the way we'd use it most, is written like this. So if we're given some things with something besides 10 or e as a base, we can always convert them like so.